Assalamualaikum warahmatullahi wabarakatuh. My name is Walma Bahadith, and today our group are going to present about the PCM assignment. So this is our group members. So first of all, what is PCM? So PCM or Pulse Code Modulation is a method used to digitally represent sample analog signals. It is the standard form of digital audio in computers, compact discs, digital telephony, and other digital audio applications. In a PCM stream, the amplitude of the analog signal is sampled at uniform intervals, and each sample is quantized to the nearest value within a range of digital steps. So the objective for this assignment is to understand one of digital modulation techniques. Second, to generate the pulse code modulation PCM signal using MATLAB. And lastly, to plot the pulse code modulation PCM signal using MATLAB.
Okay, Assalamualaikum. My name is Yasmin Batusha. So, this is the MATLAB coding for example 1. Basically, this coding is used to see the PCM process. For example, in this line, it tells MATLAB to generate a sine wave with the frequency of 1 Hz. And in this line, it tells MATLAB to generate a square wave with the frequency of 10 Hz. We also have encoder and decoder syntax for this signal, and finally plot syntax to plot the graph. So, this is the analog signal. This is the sampled signal. This is the encoded signal. This is the decoded signal. And this is the square signal. Next, we proceed to Simulink to compare the result. So, this is the MATLAB blocks we use for example 1. This is the value for the sine wave block. This is the value for the square wave block. This is uniform encoder for encoding. This is uniform decoder for decoding. This is the scope for graph plotting. Then we run the program. So, this is the analog signal. This is the sampled signal. This is the encoded signal. This is the decoded signal. And last but not least, this is the square signal. And that's all from me. Thank you.
Assalamualaikum, my name is Siti Nur Aisyah. So this is the MATLAB coding for example 2. So basically, this coding is used to see the compounding process. For example, in this line, it tells MATLAB to generate a sine wave with the frequency of 1 Hz. And in this line, it tells MATLAB to compress the signal using mu law, one way of quantizing. This line for encoding the signal after quantizing. This line for decoding the signal after receiving. This line for expanding the received signal. And finally, this line for plotting the graph. Then we run the coding. So this is the received signal without compounding. This is the received signal using compounding. We proceed to Simulink to compare the result. This is the value for the sine wave block. This is the value for the uniform encoder with 3 bits. This is the value for the uniform decoder with 3 bits. This is mu law compressor for compressing. This is mu law expander for expanding. This is the scope for graph plotting. Then we run the program. So this is the received signal without compounding, and this is the received signal using compounding. That's all from me. Thank you.
Assalamualaikum and hi. My name is Siti Nusharina binti Mahyuddin, and I'm going to present the exercise for question 1. So the question asks, what is the frequency of the analog signal that has been used in the example 1? So the answer is, the frequency of the analog signal that has been used is 1 Hz. It is determined by the sine 2 times pi times t function. So if we look at the coding is the same as example 1. The line 3, press the function will determine the frequency.
For example 2, here you can see I have opened the scope with and without compending, and then for uniform encoder we set to 3 bits, and for uniform decoder we set to 3 bits. Same goes to without compending. So here we set to 3 bits, and then we set to 3 bits. Okay, and then we can run the simulation, and then we will wait for it to be done. Okay, now it's done already, and I will open the scope for with compending. So here it is a graph, and this is without compending. And now we will see with 4 bits. We change the uniform encoder and decoder. Also for without compending, we change the uniform encoder for 4 bits and uniform decoder for 4 bits. And then we can run, and this, as usual, we wait for it to be done. Then we can open the graph here. As you can see, this with compending, and another one without compending. And after done the MATLAB simulating, so we will open the MATLAB, and this is the code which is we declare the time, this is the signal, and then encoding the signal and also decoding the signal. And then for the graph we use the function plot, which is it have two figure 1, figure 2. Figure 1 refer to with compending, and figure 2 is referred to without compending. So here is the result for figure 2 and figure 1. And then after that we will change the n level to 16, and then we will run the simulation, and we will see the result for figure 1 and figure 2. And this is how we calculate the SQNR for each level, which is 8 and 16. So the formula for BEET is log 2n, and formula for SQNR is 6.02 multiple n and then plus 1.76. So for level 8, the answer is 19.82, and then for level 16, the answer is 25.84.
So we proceed to the discussion of the assignment. So basically, we discussed about the result in our discussion. So in this assignment, we use PCM to digitally represent analog signals. Based on our results, PCM involves sampling the analog signal at regular intervals and quantizing each sample into a discrete value. PCM is generally noise robust and can be removed by using higher bits per sample. In other words, we use compending to improve the efficiency of the quantization and reduce the noise. The greater the SQNR value, the higher quality of received signal can be obtained.
From our observation, the output for the exercise for both MATLAB and Simulink are nearly identical. MATLAB approached the task by coding process, while Simulink approached the task by using simulation of block. This proves that both software are useful in doing PCM. I'm going to present the conclusion. To sum up, the purpose of this project was to acquaint students with MATLAB-based Pulse Code Modulation or PCM. We acquired the ability to construct, encode, decode, and visualize PCM signal by working through the given examples and activities. The MATLAB code's usage of compending illustrated how it affects signal growth and compression. We investigated subject as quantization at 2 separate levels, n equal to 8 and n equal to 16. Sinusoid production and analog signal frequency determination. The quantized signal's quality was evaluated by calculating the signal to quantization noise ratio, which is SQNR. By integrating MATLAB simulating, we were able to compare the performance of various modulation strategies, which gave a practical dimension to our learning. That's all from me. Thank you.